we are now recording. So let me try to share the screen. So a long time ago, we had our last exam. You should have gotten your exam score. If you didn't get it, let me know. And along with it, I gave you your midterm grade. Okay, so you should know how you're doing as of now. Okay, I tried to send you a message through Canvas announcements to what we had left. So again, from the original schedule, just move everything up a day, right? So schedule for now is 10.1, 10.2, 3, 4, 11, 1, 11, 2, and exam on Tuesday, the 27th. And then if we move everything here up a day, then our last exam should be on Thursday, the 13th. And the final exam will now be on the 20th, it looks like. Okay, so again, just kind of move everything up one day. This is our tentative plan, okay? So that's where we're at. The chapter we just finished is our longest chapter. So we're on to 10.1. There are 6 sections for the next test, 10.1, 2, 3, 4, 11, 1, 11, 2. Then the last test only covers 4 sections, 12, 1, 2, 3, and 13.2. And here's the assignment. And as usual, I'll end up doing the evens and you do the odds, so 10.1. Okay, we will have a quiz on Thursday on 10.1 material. So the stuff that we do today. Okay, all right, so let's get started. So what are we doing now, right? So we're doing quite a bit of graphing and techniques of graphing now. Okay, so 10.1, page 630, relative maxima and minima. These are the plurals of maximum and minimum. Okay, if you say, what are these funny words? So maximum, minimum, these are the singular forms. So the plural, these are the plural. Okay, 1 maximum, 2 maxima. You're not supposed to say maximums. And 1 minimum, 2 minima. You're not supposed to say minimums. Okay, so singular, plural, maximum, maxima. Singular, minimum, minima. And we're going to do some curve sketches based on that. Right, relative maximum, relative minimum, page 630. Now, I don't think you have to put all this on your next cheat sheet, on your next formula sheet. It's a very formal definition. There's nothing wrong with it. But I think you can survive without it. I think it's a lot better if you just look at a graph. Okay, so here's a picture. This is a relative maximum, relative minimum, right? High point, low point. And we say relative. Sometimes you'll see some books use the word loco. Okay, so loco max or min is the same thing as relative max or min. So here's a relative maximum. If I just look at a small neighborhood of this point, okay, only look at a small neighborhood right there. Okay, that's the highest point. Now, there are other points on a graph that are maybe higher, like there's a point over here that's higher, but relatively speaking, in a small neighborhood of that point, it's the highest point. Likewise, this is a relative minimum down here. If I just look at a small neighborhood of that point, if you only look at that space between my 2 pens, okay, that's a minimum. Now, if I look at the whole graph, there may be other points that are lower, but relatively speaking, locally speaking, it's a minimum point. Okay, so that's what we're going to figure out now. Okay, so I would say don't put any of this on your cheat sheet. You don't really need it. Just look at the picture, right? Maximum, minimum. Right, increasing and decreasing functions. You might want to put this on your cheat sheet. Okay, now remember, derivative gives me slope. Okay, so let's take a look at this graph. Now, in our frame of reference, we're always going to go from left to right. We're never going to go from right to left. It's always left to right. Think of a roller coaster, if you like roller coasters. Okay, I know they started to open up some amusement parks. Okay, as I move from left to right, here you would say you're increasing. I'm going up, decreasing, increasing, right? Decreasing, increasing. So how do I tell using calculus if the graph is increasing or decreasing? Well, remember, derivative means slope. So think back to algebra 1. Slope positive means the line goes something like that, right? Increasing. Slope negative means the graph is something like that. Okay. So we have these rules. So you can put this on your next cheat sheet if you want. F prime of x greater than 0 for all x in AB, then F is increasing. Okay. Positive slope, F is increasing. Again, frankly, if we were meeting face to face, I'd make you memorize this, but it's really not that hard. Think of your algebra 1 class, right? Positive slope. See, oh yeah, positive slope. The graph is going like that, increasing. Negative slope. The graph is decreasing, something like that. Okay, so everywhere here, the graph is increasing, positive slope. Everywhere here, negative slope, decreasing. I'm going down the roller coaster, right? And then I'm going back up again, so positive slope. This graph looks like a parabola. Negative slope, negative derivative, positive slope. So positive derivative, right? So F prime of x greater than 0 means F is increasing. F prime of x less than 0, decreasing. Okay. Page 631. You can put this on your next cheat sheet. All right, let's look at a relative maximum and minimum. Okay, so on the bottom of page 631. Okay, relative max. And I'll do the same abbreviations that they use, the 3 letters. So maximum, I don't feel like writing maximum. You don't feel like writing maximum. I'm just going to put max. I don't feel like writing minimum. You don't feel like writing minimum. Just put min. I don't feel like writing relative. You don't feel like writing relative. Just put REL. Okay. Or again, I might write loco, LOC. All right. So relative maximum, relative minimum, relative maximum. Okay. What seems to be true about the derivative right here? Slope is 0. Slope is 0. Here, the slope is undefined. This is a corner point we talked about before, right? Okay, so we have this rule. If we have a relative max or min, then either the derivative is 0 or it's undefined. If f has a relative maximum or relative minimum, then the derivative is either 0 or undefined. Okay, those of you that are on roller coaster rides, it doesn't have to be, say, I don't like roller coaster rides, or if you're in a, you've all been in a car or a bus, goes like this, right? Increasing, decreasing. Right at the very top, the slope is 0, right? Can you imagine on this roller coaster, on this ride, okay, you're going up. Then just ever so slightly for an instance, slope is 0, and then you go back down. Okay, you go down, slope is 0, then you go back up. And then right here, the derivative isn't even defined. It's a corner point, right? So if I have a relative max or min, derivative is 0 or undefined. Something called critical point, critical number. What is a critical point or a critical number? Okay. At any point where the derivative is 0 or undefined, we call that a critical point. Okay, see that right over here? I'm not sure I can point it out to you, and maybe right there. Okay, so critical value or critical point. A point is an x and a y. Critical value is just the x coordinate, right? So x, critical point, a point is an x comma y. Okay, derivative is 0 or derivative is undefined. Okay, so if you want to put that down, you may. So what is a critical value? An x value where the derivative is 0 or the derivative is undefined. They don't box this out and they don't put it in green, but you can put that down if you wish. Okay, other books do that. Okay, critical value, derivative is 0 or undefined. If you find a y coordinate, now it becomes a so-called critical point. Okay, what's so good about having those? You might have a maximum or minimum at those critical points. Okay, so let's take a look over here. Critical point, derivative is 0. critical point, derivative is undefined. Looks like a minimum, derivative 0, critical point. Derivative is undefined, critical point. Okay, that looks like a maximum, right? Minimum, minimum. How can you tell if you have a maximum or a minimum? That looks like a maximum. What happens on the left side? Function's increasing. What happens on the right side? Function's decreasing. Same thing here. Think of a roller coaster ride. You're going up, you reach the top, then you go back down. That makes this a maximum. Same thing here. You go up, then you go down. What makes a point a minimum? Well, if I'm a little bit to the left, I'm going down the roller coaster ride, right? And if I move a little bit to the right, I'm going back up. The ride's going like this, down and up. If you don't like roller coasters, this could be driving, or you're on a bus, right? If it goes like that, you reach the bottom. Same thing here. You go down, then you go up. Okay. It's possible that you can have a slope of 0, but you don't have a maximum or minimum. Okay. That might happen. Let me show you something called a horizontal point of inflection. Fancy words. That's too much to say. Can you think of a good abbreviation for this? HPI. The book even uses HPI later, point of inflection or inflection point. So what does that mean? Here the slope is 0, but it's neither a maximum nor a minimum, right? There are points that are lower, there are points that are higher. You're going up. I've seen rides like this, haven't you? Roller coaster rides that go like this. You go up, you level out just for an instant, and then you go back up. Okay. So this is neither a maximum nor a minimum, even though the derivative is 0. Okay. This is called a horizontal point of inflection, or HPI. We'll talk more about points of inflection or inflection points in section 2. I'll do that on Thursday. But it's possible to have a slope of 0, but you have neither a maximum nor a minimum. And I'll show you how you can tell that. Okay. All right, so we're going to get started with some of the problems here now. Quickly over the highlights. So what do you really need to know? Maximum, minimum, high point, low point, right? Local maximum or relative maximum, local minimum, relative minimum. How can you tell if the graph is increasing or decreasing? By the derivative. F prime of x greater than 0, i.e. slope, right? Remember, derivative gives me slope. Slope is positive. Then the function's increasing. F prime less than 0, slope negative, function's decreasing. Okay. Critical value. Derivative is 0 or undefined. Plug in to find the y coordinate, you get a critical point, so-called. Okay. To have a maximum or minimum, you look at the critical points. Okay. The derivative is either 0 or undefined. Is that picture right? Look at the max and min. The derivative is either 0, 0, 0, or undefined. Okay. We're going to learn how to find these points. You have a maximum if you go from increasing to decreasing. I mean, imagine you're hiking. You're hiking. Here's a maximum point. You're standing up here, right? So what happened? You went up, and then after that, the only way you can go is down. So you reach the maximum. How about a minimum? Well, to the left, you're decreasing. You go down, you've bottomed out. You're not going down anymore. The only way you can go is up. So that means you reach the minimum. Okay. All right, so we're ready. All right, so looking at our assignment, what do we have here? So 10.1, 7 to 10, 15 to 20, 25 to 30. Okay, again, I'll do evens, maybe some odds depending on the time. See how it goes. So starting at problem 7. So page 640 for those of you who don't have the book and aren't getting it. So there's 7, 8, 9, 10. And then what else are we supposed to do? Can't see what I had there. 15 to 20 at the bottom here. In the directions. And what else did we have? 25 to 30. Okay. Right, so here we go. So I'll do 8, you do 7, I'll show you 10, you do 9, and so on. All right, 10.1, obviously ignore any dates. All right, number 8, what's happening with the graph? Take the derivative. Y equals x cubed minus 3x squared plus 6x plus 1. Okay, so the derivative is 3x squared minus 6x plus 6. Set it equal to 0. I can factor out a 3. 3 times x squared minus 2x plus 2 equals 0. Well, 3 can't equal 0, so I have to set this equal to 0. X squared minus 2x plus 2 equals 0. This is not factorable, so use the quadratic formula. A is 1, B is -2, C is 2, right? So x is equal to -b, +2, plus or minus the square root of b squared, -2 squared is 4, minus 4ac, 4 times 1 times 2 over 2 times 1. This is 4 minus 8, which is -4. Okay, can't do it for real numbers. So this expression, x squared minus 2x plus 2, can't equal 0. So in this simple first case, there's no critical points. So I guess this problem was too easy because they started off with no critical points. But don't worry, we'll do some quickly enough where there are critical points. Which means this graph is always either increasing or decreasing. How can you tell? Just plug in any number you want. Okay, what's the easiest number to plug in? 0. Plugged in 0, 0, 6. Okay, so the function's always increasing. Okay, my abbreviation for increasing is an arrow going up. Instead of writing INCREASING, arrow up, which is very suggestive. It's going that way. So f is increasing for all real numbers. Another way to write all real numbers is -infinity to infinity. F is decreasing, so decreasing my abbreviation is an arrow down. It's decreasing nowhere. Okay, so that was kind of an easy first example. So let me do one where it's not that straightforward. Okay, number 10. Y equals 15x cubed minus x to the 5th plus 7. So this one actually will have stuff. Okay, so make a sign diagram, determine maxima and minima. So what's maxima? Plural of maximum. What's minima? Plural of minimum. Okay, so those are the plural forms. All right, so this one's got some stuff. Okay, take the derivative. Derivative of that is 45x squared minus 5x to the 4th, and the derivative of 7 is 0. Set this equal to 0. Technically, I'm also supposed to see when is the derivative undefined. It's a polynomial. It's always defined. This one's always defined. It's a polynomial. Okay. Will there be examples where the derivative is not defined? Yes, and I'll show you that when we get to it. Okay, factor. Common factor is 5x squared, right? I can take a 5 out of 45 and 5. X squared and x to the 4th, I can take out x squared. So 5x squared parentheses 9 minus x squared equals 0. Okay, and of course, remember, you can always double check your factoring by multiplying it back out, right? That times that is 45x squared. That times that is a minus 5x to the 4th. This further factors into 3 plus x, 3 minus x. Okay, so y prime is 5x squared times 3 plus x, 3 minus x. Set it equal to 0. Right, so what makes this 0? 0. What makes this 0? Negative 3. What makes this 0? Positive 3. Right, so here's what you do now. We make a sine chart. Okay, so I write down a real number line. I place down the critical numbers, which are 0, negative 3, and positive 3. Here's my real number line. Okay, temporarily ignore the red. Okay, we're going to have to derive the red. Okay, if I plug in negative 3, I get 0, right? Put a negative 3 here, here, and here. 3 plus a negative 3 is 0, so 0 times all the rest is 0. If I plug in 0 right there, and right there, and right there, 5 times 0 squared is 0, so 0 times the rest is 0. And likewise, if I plug in 3 here, here, and here, well, 3 minus 3 is 0, so 0 times all that is 0. Okay, so pretend you don't see the red right now. I know that's almost impossible. Pretend you don't see that. Okay, at negative 3, 0, and 3, when I plug in, I get 0. So if I plug in any other number, I do not get 0. Does that make sense? So if I don't get 0, it's either going to be positive or negative. So I determine the sign. Is it positive or is it negative? So I pick something here, 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 and here, and check the sign. Okay, so what's all this table here? Okay, I pick something smaller than negative 3, negative 4. Something between negative 3 and 0, negative 1. You could also pick negative 2. Something between 0 and 1. I picked 1. You could also pick 2. Something bigger than 3, 4. You could pick 5. You can pick 6. You can pick 80. You can pick 1,000,000. But this will do. Okay. Plug into the expression for the derivative. 5x squared, 3 plus x, 3 minus x. I know I put equals 0. Temporarily pretend it's not there. Plug in, determine the sign. So I plug in negative 4 here, here, and here. Then I plug in negative 1 here, here, and here. Now, it might be quite a bear to find the exact value. That's why we don't care about the exact value. We just need the sign. Is it positive or is it negative? So when I plug in negative 4 here, here, and here, I only want the sign. I don't care about the exact value. Now, furthermore, look at this, 5x squared. What do you know about 5x squared? If I plug in a positive, it's positive, clearly. But what happens when you plug in a negative and square it and multiply by 5? It's still positive. This thing right here, 5x squared, no matter what I plug in, besides 0, and I'm not plugging in 0, it's going to be positive. That's reflected in all of these being plus. See this plus, 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 plus? That means 5x squared is always positive. Doesn't matter what I plug in. Okay, so I don't have to do these. I just check here and here. Plug in negative 4. 3 minus 4, negative. 3 minus a negative 4, that's 3 plus 4, positive. So if a positive times a negative times a positive, that comes out to be negative. Hence, minus sign over here. Okay, temporarily pretend you don't know these here. Okay, plug in negative 1. I already know this is positive. 3 plus a negative 1, positive. 3 minus a negative 1, positive. 3 positives, multiply them together, positive. Put a plus there. 1. We already know that's positive. 3 plus 1, positive. 3 minus 1, positive. Positive times positive times positive, positive. Finally, 4. We already know that's positive. 3 plus 4, positive. 3 minus 4, negative. Positive times negative, negative. minus, plus, plus, minus. Okay, derivative is negative, functions decreasing, decreasing. Derivative is positive, increasing, increasing, right? So from that sine chart, I'm using this rule. I can find it. Page 631, right? Right there. F prime greater than 0, F is increasing. F prime less than 0, F is decreasing. Right? Now, relative max, relative min, or neither. -3. The graph goes down, then it goes up. Okay? Your roller coaster ride goes down, goes up. That's a minimum. So x equals -3 is a relative minimum. If you can't read that, that's REL for relative minimum. How about at 0? Goes up, and then still goes up. That's neither a max nor a min. That's a horizontal point of inflection. So x equals 0, HPI, horizontal point of inflection. So it goes up, levels out, and then goes back up. Okay. So you roller coaster aficionados, seen rides. Okay, you go up, then it levels out just for, and then it shoots you back up. Right? Horizontal point of inflection. How about x equals 3? Increasing, decreasing. So the ride goes up. Imagine you're on a ride. It goes up, right? And it comes down. Maximum, relative maximum. So here's an example where we got all three of them. I got a relative minimum, a relative maximum, and neither, horizontal point of inflection. So there we go. Side note, but yeah, people who build roller coasters, all of this stuff comes into play, right? Where's the graph increasing? Where's it decreasing, right? Do we want to make the ride go like that or like that and whatnot? Okay. Of course, usually when people go to amusement parks, they don't think about that. You know, they just want to ride the rides or whatever, right? But there's a very good mathematics behind roller coaster rides, as you might guess. Well, it better be, otherwise it's not going to work. Okay. Show you 16. X squared plus 4x. Okay, find a derivative, A. B, find the critical values, find the critical points. What's the difference between B and C? Critical value is only the x coordinate. Critical point gives you the y coordinate. D, find the values where the function's increasing and decreasing. And then determine maxima, minima, point of inflection, and all that stuff. Okay. X squared plus 4x. Take the derivative. 2x plus 4. Set it equal to 0. Yes, technically I have to say when is it undefined, but 2x plus 4 is always defined. There's no trouble spots. See, when is there a trouble spot? Well, if you're dividing by 0 or taking the square root of a negative, maybe. Okay, but we'll worry about it when it comes to that. I'll show you. Okay, simple algebra, subtract 4, divide 2. X equals -2. That's called a critical number. To get a critical point, plug in to find y. So f of -2. -2 squared plus 4 times -2. That's 4 minus 8, -4. Okay, so -2, comma, -4. Okay, so critical number, -2. Critical point, -2, comma, -4. Now I do my sine chart. Okay, y prime was 2x plus 4. Okay, I don't make a sine chart for this one because it's pretty easy to just plug in, I think. Okay. Okay, what happens when I plug in -3? 2 times -3 plus 4, that's negative. Minus. What's a number bigger than -2? 0. 2 times 0, 0. plus 4, positive. Derivative negative, decreasing. Positive, increasing. Okay, you want to get used to this. This is intervals of increase and decrease. The function is decreasing from negative infinity to negative 2. It's going down. Then the function's increasing, arrow up, from negative 2 to infinity. So these are called intervals of increase and decrease. When's the graph going down? When's it going up? When's the roller coaster going down? When's the roller coaster going up? You want to know that if you're building, if you're constructing a roller coaster, or even if you're riding a roller coaster, right? You ride the ride, you look at the rides, okay, here I'm going down, here I'm going up. Now, if you go down and then you go up, this must be a minimum. So negative 2, negative 4 is a relative minimum. In fact, I'll be even stronger and say it's an absolute minimum. It's absolute, we'll do some more absolute maximum minimum later, but it's absolutely the lowest point in the graph. So how do I know that? Because all the graph does is it goes down and then it goes up. Right? So there we go, absolute minimum. All right, so that was 16. Yeah, I'm going to jump to 26. If I have time, I'll come back to more. 26. Y equals 1/4 x to the 4th minus 2/3 x cubed plus 1/2 x squared minus 2. Okay, so find relative maximum, minimum, horizontal points of deflection. Sketch the graph if possible. Okay. Now, I don't like the fractions, but when you take the derivative, it actually comes out very nice. Because if you take the derivative, right, what's 4 times 1/4? 1. So 1x cubed. This is nice. Negative 2/3 times 3, 3 cancels out, minus 2x squared. This is nice. 2 times 1/2, 1x. And the derivative of negative 2 is 0. Okay, so here's the derivative, set it equal to 0. Factor out the x. X times x squared minus 2x plus 1 equals 0. This further factors into x minus 1 squared. Okay, so fully factored x times x minus 1 squared equals 0. So get my critical numbers. Okay, set this equal to 0. I would again set it equal to undefined. This is always well defined, so no worries about that. So either x is 0 or x is 1. Plugging in 0 is pretty easy. 0, 0, 0, negative 2. 0, comma, negative 2. Plugging in 1 is not easy. Well, 1 to the 4th is 1. 1 cubed is 1. 1 squared is 1. So I have 1/4 minus 2/3 plus 1/2 minus 2. Okay, so ignore the red. 1/4 minus 2/3 plus 1/2 minus 2 over 1. Then in red, I got a common denominator of 12. So this one, 3 over 3, right? 4 over 4, 6 over 6, 12 over 12 to get a common denominator. That becomes 3 minus 8 plus 6 minus 4, negative 23 over 12. Very clumsy. 1 comma, negative 23 over 12. Now, this was 0, negative 2. Negative 2 is negative 24 over 12, right? This is negative 23 over 12. So this is a little bit higher, ever so slightly higher by 1/12. Right, sine chart. Y prime, where'd it go? X times x minus 1 squared. Okay, I lay down 0 and 1. Okay, temporarily ignore this. Ignore the arrows, just 0 and 1. Why 0 and 1? Because that's where the derivative was 0. Plug in 0, you get 0, right? Plug in 1, you get 0. If I plug in any other number, I do not get 0, which means it's either positive or negative. So pick something here, something here, something here. So to the left of 0, -1. Between 0 and 1, okay, 0.5. Bigger than 1, 2. Once again, tell me something about x minus 1 squared. It's blah, blah, blah squared. Always, what sign? Always positive, right? You're squaring it. So if the thing behind this pen is a positive, you square it, it's positive. If the thing behind my pen is negative, you're going to square it, still positive. So plus, 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 these three pluses represent plugging into x minus 1 squared. So the sign is completely determined by this. Well, -1 is negative, 0.5 is positive, and 2 is positive. So negative, positive, 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 positive. Okay, negative times a positive, negative. Positive times a positive, positive. Positive times a positive, positive. Negative derivative, decreasing. Positive derivative, increasing, increasing. Okay, if the roller coaster goes down, then it goes up. What do you have right here? Minimum. 0, -2, minimum. The ride goes up, levels out to a slope of 0, and then goes back up. So you have neither a maximum nor a minimum. Horizontal point of inflection. So 1, -23/12, horizontal point of inflection. Okay, so here's the graph. Function decreasing, then increasing, then increasing. Down, up, up. Okay, down, then up. So 0, -2 is a minimum. Comes right here, increases to 1, -23/12, and then it goes back up again. So you have a horizontal point of inflection. Okay, I've seen rides like this, right? You ever seen a roller coaster ride like that? Goes up, down, up, goes up, levels out to 0, and then shoots back up again. Okay. All right, so that's what we got. Okay, next one I want to show you was 28. C of x. They might as well say y, but c of x might be a cost function. X cubed minus 3/2 x squared minus 18x plus 5. Okay. So this one's a little bit more involved. So take the derivative. 3x squared. Very nicely, the 2's cancel out, right? So minus 3x minus 18. Factor, common factor of 3, x squared minus x minus 6. That factors into x minus 3, x plus 2. Set it equal to 0. Again, I'm supposed to say set it equal to undefined, but this is never undefined. So we're good. Okay, so by the 0 factor property, either this is 0, impossible. How can 3 be 0? This is 0, x equals 3. This is 0, x equals -2. All right, plug back into the original. Okay, it's messy. You have to take my word for it. But put in 3 cubed minus 3/2 of 3 squared minus 18 times 3 plus 5. Okay, to save class time, I did it already. -35.5. 3, -35.5. Same thing with -2. Plug in -2 here, here, and here. So it's -2 cubed minus 3/2 times -2 squared minus 18 times -2 plus 5. Grind that all out. You can take my word for it. 27. Okay, so -2, 27. Okay, sine chart. C prime is 3, x minus 3, x plus 2. Lay down -2 and 3. How come? These are two values where the derivative comes out to be 0, right? Plug in -2 here and here, -2 here, -2 plus 2 is 0, so 0 times all that is 0. Plug in 3 here and here, well, 3 minus 3 is 0, so 0 times the rest is 0. Derivative is 0, derivative is 0. So everywhere else, the derivative is not 0. If the derivative is not 0, it's going to be either positive or negative. Determine the sign. Okay, so pick something here, here, and here. Smaller than -2, -3. Between -2 and 3, 0. I like 0. You should always plug in 0 whenever possible. This thing's blinking back and forth, red, yellow and white. Over here, 4. Now what's this plus, plus, plus? That represents 3. There's nothing to plug in. 3 is positive, right? So this plus, this plus, this plus is a 3. Okay, now for the variable expressions. -3. -3 minus 3. -6, negative. -3 plus 2. -1, negative. So I have a positive times a negative times a negative, positive. Middle region, 0. 3 is positive. 0 minus 3, negative. 0 plus 2, positive. Positive times positive, negative. Four. 3 is positive. 4 minus 3, 1, positive. 4 plus 2, 6, but the main thing is that it's positive. Positive times positive times positive, positive. Increasing, decreasing, increasing. Intervals of increase and decrease. F is increasing from -infinity to -2. If you have more than one region, you join it with a U for union. Union 3, infinity. F is only decreasing between -2 and 3. Okay, so up, down, up. Okay, roller coaster goes up, then down, maximum. Roller coaster goes down, then up. I say roller coaster, it can be walking or riding or driving. Minimum. So -2, 27 is a maximum. 3, -35.5, minimum. So here's the graph. Okay, it goes up, down, up, up, down, up. So here's my maximum, here's my minimum. So the ride, if you would, the roller coaster ride goes like this, goes up, and you go down, and you go up, right? And we've seen rides like that, right? Okay, so I'm done with that. I'm about to show you the next page, but let me do my focusing thing again, in case you didn't quite get it. So focus in case it didn't come out. You can watch the video. Okay, and then 16 and on. And then over here. Okay, and then let's see, 28 that I just did. Okay, again, I know I'm going fast, but you can always pause the video anytime you want. And yeah, let me get you the graph. See if we can show you the graph in one picture. Yeah, I think that does it. Okay. Okay, then some other interesting ones. Yeah, I'm going to show you 19. Yes, I know it's an odd one. And 20, because they're a little bit unusual. Then if I have time, I'll go back and do some more. X to the 2/3. The derivative is 2/3 x to the negative 1/3. 2/3 minus 1 is negative 1/3. Okay. This means cube root on the bottom, right? 2/3 cube root of x. Right? First, I set it equal to 0. But this is impossible. A fraction is equal to 0. Stop and think about it. You have a fraction, like a over b. When is it equal to 0? When the top is 0. Right? If you have a over b equaling 0, a has to be 0. It can't be 1, 3, negative 5. It's got to be 0. But the top can't be 0 because it's already 2. So this is impossible. But I do have a critical number now, x equals 0, because the derivative is undefined at 0. So here's our instance where the critical number isn't because we set it equal to 0, but because x equals 0 is undefined. So I still do the sine chart analysis because x equals 0 is a critical number. The critical point is 0, 0. Plug in 0, 0 to anything is 0. So y prime is 2/3 cube root of x, if you can't see it. Yeah, if I raise it up, you see cube root of x. Okay, pick something here and something here. Well, it's pretty easy. If I plug in negative 1, the cube root of negative 1 is negative 1. That's positive, multiplied by negative 1, it's negative. Plug in positive 1, it's all positive, right? 2 is positive, 3 is positive, cube root of 1 is 1, that's positive, positive. Decreasing, increasing. Okay, so f is decreasing from negative infinity to 0, and f is increasing from 0 to infinity. Okay, so the derivative is not defined, so I must have a corner point. Okay, and indeed the graph looks something like this. It bounces like so. Okay, corner point at the origin, 0, 0. All right. The graph is actually finished, but I'll just say something more about derivative not being defined for you roller coaster buffs. Okay. At a point where the derivative is not defined, that's what I call a dangerous point on a roller coaster. This doesn't look right to me, right? If I saw a roller coaster that looks like that, I'm not getting on it. I don't know about you, right? It doesn't look right. It looks like you're just going to crash into the ground, right? You got to have a smooth transition, right? Okay, that means you can draw a tangent line, essentially, right? Like stuff like this, smooth. I don't mind going on a roller coaster like this, right? Smooth, okay? So if you think of roller coasters, they can twist you, turn you upside down or whatever, but it's all smooth. There's a tangent line. This does not look like a good roller coaster. I do not want to go on that ride. It doesn't look right. It looks like it's just going to crash into the ground, right? They don't make roller coasters like this. Okay. So there has to be able to be a smooth transition, a smooth tangent line. Okay. I'm going to go back and do another odd problem, number 9. Show you what that one's like. 2x to the 5th plus 5x to the 4th minus 11. Make a sign diagram, determine maxima and minima. All right, so find a derivative. That's not too hard. 10x to the 4th plus 20x cubed. Set it equal to 0. And again, set it equal to undefined. This is never undefined, right? I'm not dividing by 0 or anything like that. So just set it equal to 0. Okay, I can factor out a 10 and an x cubed. And then I don't know why it switches from yellow to white sometimes, but anyway. 10x cubed, x plus 2. Set it equal to 0. Okay, what makes this 0? 0. What makes this 0? Negative 2. So these are my critical numbers. What's critical number? Derivative is 0 or undefined. Put a 0, you get 0. Put a negative 2, you get 0. Okay, to find critical points, plug in. What do you get when you plug in 0? 0 plus 0 minus 11, negative 11. Negative 2 is a little bit harder. Put negative 2 right there and negative 2 right there. 2 times negative 2 to the 5th power plus 5 times negative 2 to the 4th power minus 11. 2 times negative 32 plus 5 times 16 minus 11. Negative 64 plus 80 minus 11. You can take my word for it. It's 5. 2 comma 5. Make my sign chart. Put the expression for y prime 10x cubed times x plus 2. What do I lay down? The critical numbers, 0 and negative 2. Negative 2 and 0. Of course, you got to put them in the right location. Negative 2 to the left of 0. All right, pick something over here, negative 3. In the middle, negative 1. Over here, positive 1. Plug in 10 times negative 3 cubed, that's negative. So you don't care about the exact value. It's too difficult. Just want the sign. Negative 3 plus 2. Negative 1, negative. Negative times a negative, positive. Negative 1. 10 times negative 1 cubed. Negative 1 times negative 1 times negative 1 is negative 1 times 10. It's negative. Negative 1 plus 2, positive. Negative times positive, negative. This region, 1. 10 times 1 cubed, positive. 1 plus 2, positive. Positive times positive, positive. Plus minus plus. Positive derivative, increasing. Negative derivative, decreasing, increasing. So intervals of increase and decrease. F is increasing from negative infinity to negative 2. Union, meaning more than one interval, 0 to infinity. And the function f is decreasing only between negative 2 and 0. All right, what's true at negative 2? The roller coaster goes up, down, maximum. Negative 2, 5 is a relative max. 0 comma negative 11. Decreasing, increasing. The ride goes down, then it goes up, relative minimum. So there it is. So here's the graph. Increasing, decreasing, increasing. Negative 2, 5 is a maximum. 0 comma negative 11 is a minimum. Okay. All right, I'm done with that page. So again, let me do the focusing job for you, in case you couldn't see what I have. And I believe I'm down to the last problem, so I'll be finished after this. And then if you have any questions, you can ask, and if not, then we're done for the day. And there's 19 again. Okay, so the last one I have on top is question 20. It's sort of like 19. Let me just double check that I don't have anything else in my notes. Yeah, I think we're good. Okay. Number 20. Y equals negative x minus 3 to the 2/3 power. Again, that fractional exponent there. Okay, so the derivative is -2/3 x minus 3 to the -1/3. Then by the chain root times the derivative of the inside, but that's just 1, so you don't have to write it. And just like the previous problem, -1/3 exponent means cube root in the denominator. And just like before, if I try to set it equal to 0, I can't, right? When is a fraction equal to 0? When the top is 0. Top's already -2, so impossible. But x equals 3 is a critical number because I see a fraction. So I say to myself, oh yeah, you can't divide by 0. What number plugging in gives me a 0? That would be 3. So x equals 3 is a critical number. Okay, and by the way, what's the y coordinate? Plug in 3. 3 minus 3 is 0. 0 to 2/3 is 0, and -0 is still 0. So I have 3, 0. Sine chart. Okay, this one's easy enough that I didn't even bother writing what's happening. Plug in 0 on this side. 0 minus 3 is a negative. Cube root of a negative is a negative. So negative divided by negative, positive. And something to the right of 3, how about 4? 4 minus 3 is 1. Cube root of 1 is 1, positive. But a negative in front of the whole thing makes the whole thing negative. So positive, negative. Increasing, decreasing. That means 3 zeros a max. Okay, so if we want intervals of increase and decrease, f is increasing from -infinity to 3, and f is decreasing from 3 to infinity. Okay. But I don't have a nice derivative like 0, so it must be a corner point. So it must look something like this. Bounces off like this. So again, you don't make a roller coaster like that. That doesn't look right. Right? Looks to me if I'm on this roller coaster, it wouldn't continue on the track, it would just fly up, it looks like, right? Okay, so this is a very dangerous roller coaster, so to speak. So there we go. All right, so I'm done for today, folks. So you will get a quiz on the end of class Thursday and stuff like this. Let me raise this up so you can see it. All right, so next time we're going to do the next section. Okay, so 10.2, we will learn more about points of inflection or inflection points. Okay, 10.2, page 643. We're going to deal with something called concavity, whatever that means. And points of inflection, we've already seen that a little bit. Okay, so we'll see that. So we'll do 10.2, and then at the end of class on Thursday, we will have a quiz. All right, so it's about 5:40-ish now. Okay, anybody has any question? Otherwise, we're done for the day. Okay, any questions, please? Okay, I don't see or hear anything, so that'll be it for tonight, folks. All right, so have a good night, and we'll see everybody next time. Okay, all right, bye, everybody.
Thank you.
Thank you.
Bye.
Bye, good night. Okay, Din, I got you.